numbers 34 and 35 on the back side of your notes packet where I gave you the writing and naming ionic compounds homework. These two, I want to make sure that we're understanding what's going on with the formulas, because a lot of students incorrectly call this canceling out, and that's not really what's happening here. So if I have something like Ca and O combining together, this came from the two ions of calcium that has a +2 charge and oxygen that has a -2 charge. So when you crisscross it, it becomes Ca2O2 that we then reduce by 2 and turn it into just CaO. But a lot of students, when they see this, they think that the +2 and the -2 cancel out, and that language or that terminology doesn't show me that you understand what's really going on. So what you can always do for any of these, I wouldn't do it for polyatomic ions because it'll get confusing, but for any compounds that are just a metal and a nonmetal combined, draw them. We practice drawing on the front page with their Lewis dot structures. You can do that for any of them. So if I look at this, what's actually happening when I combine calcium and oxygen is that I have calcium with 2 valence electrons. Since calcium is here, it has 2 valence electrons. And I have oxygen, which has 6 valence electrons. So it does have a -2 charge, but remember that's its oxidation number, not its number of valence electrons. So oxygen with 1, 2, 3, 4, 5, 6 valence electrons. When those two elements try to combine, calcium is trying to get rid of these 2 electrons and oxygen is trying to gain 2 electrons. So they're the perfect match. It's a perfect fit. That calcium is able to donate an electron here and donate its second electron here. That's how we end up with the 1-to-1 ratio that we see in our formula, where we don't need any additional subscripts. It's not that the 2 and the 2 canceled out. If I were to just draw this one, where I have 2 calciums and 2 oxygens, it would just be a completely separate situation happening, where I had calcium and oxygen, where the electrons are still getting donated, but in order to make everyone stable, these two have nothing to do with each other. I only need 1 and 1. The same thing would happen with something that had a +3 charge and a -3 charge. The thing that has a +3 charge is going to donate all 3 of those electrons to the thing that has the -3 charge. So canceling out doesn't really do a good job of describing what's actually happening in that scenario. It's really that they're just a perfect match, where exactly the number that one is trying to get rid of is exactly the number that the other is trying to gain. That doesn't answer the question that this is asking you for, though, so just to make sure that you're clear on what the homework assignment is, it's actually just to name them. So if I have Ca and O, I would call this calcium oxide. And because calcium has a predictable number of valence electrons, I don't need to include a Roman numeral. So you'll do the same thing for all of these formulas that are on the right-hand side. You'll give the name. And then for the ones that are on the left-hand side, when I give you the name, I want you to write the formula. So if I have calcium iodide, if I start with Ca and a +2 charge and iodine with a -1 charge, crisscross them to get the formula just CaI2. And that is all we have.